This is exam 4, test 4 review, detailed solution, college algebra. In this exam 4 review, we'll look at inverse function and the inverse relationship, and we'll see their graphs. Here are 3 examples. All the graphs reflect across y equals x. Then we'll look at inverse function and composition to show that f of x, for example, f of x, x plus 2 over 6, and the f inverse of x, 6x minus 2 are inverse of each other. That is, A will show f inverse compose f of x equals x. B will show f compose f inverse of x equals x. Therefore, yes, f of x equals x plus 2 over 6 and the f inverse of x equals 6x minus 2 are inverse of each other. Then we're going to show exponential to logarithm conversion. For example, 4 to the half equals 2. We're going to take log base 4. The base is 4, so we're going to take log base 4 of both sides. That is log base 4, 4 to the half equals log base 4 of 2. Then we're going to show that is half equals log base 4 of 2. Then we're going to also show logarithm to exponential conversion, such as log base b m to the 5 equals x. We're going to raise b to the x, then we're going to drop the log. That is m to the 5 equals b to the x. Then we're going to show logarithm property, such as product, power, and quotient rules, such as log x squared minus 4x minus 5 minus log x squared minus 25. That is log a over b, that is log x squared minus 4x minus 5 over x squared minus 25. And that will show that is equal to log x plus 1 over x plus 5. Then we're going to solve exponential equations such as 4 to the power of x squared plus 4x equals 2 to the 10. And we're going to solve logarithm equations such as log base 4x plus 2 plus log base 4x minus 2 equals 2. Then we're going to show some application of exponential and logarithm functions, such as compound interest, which is at equals p times 1 plus r over n to the nt, and population growth and the interest compounded continuously, which is p of t equals p naught e to the kt, where k is greater than 0. Then we're going to use TI-84 plus Finance TVM solver to solve the applications with technology using TVM solver. Then we're going to use Gauss-Jordan elimination to solve system of equations such as 2x minus y plus 4z equals minus 3, x minus 2y minus 10z equals minus 6, 3x plus 4z equals 7. We're going to convert this into matrix. For x we have 2, 1, 3. For y it's minus 1, minus 2, 0. For z it is 4, minus 10, 4, augmented with minus 3, minus 6, 7. Then we're going to do Gauss-Jordan elimination, reduced row echelon form, which is 1, 1, 1 in the diagonal, 0 above the diagonal, and 0 below the diagonal. And the result is A, B, C. That means x equals A, y equals B, C, z equals C. So when we work on this on Gauss-Jordan elimination, we'll end up at reduced echelon form, which is 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, and the result is 3, 7 minus half. That is x equals 3, y equals 7, and z equals minus half is the solution. Then we'll create this matrix in TI-84 plus. We'll call it matrix A, Then we're going to take ref of A to solve this matrix in technology. Then that will give us 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. Then 3, 7 minus half, that is x equals 3, y equals 7, and z equals minus half. Then we're going to do linear programming graphic method. This linear programming is a word problem about carpenter maximizing profit. The carpenter that makes bookcases and desks, that carpenter will make X bookcases and Y desks to maximize the profit. From each bookcase, he will make $40 profit. From each desk, he will make $75 profit. That means the objective function is profit equals 40x plus 75y, and this is to maximize this profit. Subject to constraint. For woodworking, he has only 600 hours available. That means he's going to use 600 hours or less. That is 5x plus 10y is less or equal to 600. And for finishing, he has only 240 hours available. That is, he's going to use 240 hours or less for finishing. That is 4x plus 3y is less or equal to 240. Then he has to produce 0 or more bookcases, and he has to produce 0 or more desks. And we'll use this constraint to graph the feasibility region. We'll graph these two constraints are these two lines, and he has to produce more than 0 or more than bookcases, which is x is 0 or more, that is above the x-axis, and he has to produce 0 or more desks, that is y is equal or greater than 0, that is to the right of y-axis. Then this is the feasibility region. He has less or equal than 600, that is below this graph line, and he has less or equal 240, and that is below this line. Then this is the feasibility region. Every point in the feasibility region is a profit. The maximum and minimum profit, they lie at the corner of the feasibility region. Therefore, we're going to evaluate the objective function, which is the profit, at the corners of the feasibility region to find the maximum and minimum profit. And it happened to be xy, which is x is bookcases, y is desk. He has to produce 24 bookcases and 48 desks to get a maximum profit of 4,560. That is, the carpenter shop will make a maximum profit of 4,560 when 24 bookcases and 48 desks are produced and sold. So this is exam 4 test 4 review college algebra. This is additional review to your professor instructor exam test review, which should be your main essential review. This is STEM engineering college algebra. This exam 4 review tutorials is good for students in college algebra, business math, development math, intermediate algebra, high school algebra 1 and 2. To prepare for development math algebra support, watch my development math exam 4 test 4 review video. In addition to this, I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. Number 1, inverse relationship for the following relationship. A, find inverse of 2, 4, 3, 9, 4, 16, 5, 25. That is, x is 2, y is 4, x is 3, y is 9, x is 4, y is 16, x is 5, y is 25. So as you can see, this relationship is y equals x squared. Then the inverse relationship of this is simply interchange x and y. That is, the inverse is 4, 2, x is 4, y is 2, x is 9, y is 3, x is 16, y is 4, x is 25, y is 5. So as you can see, the relationship here is y is equals square root of x. And this is the inverse relationship. B, finds the inverse of y equals x squared minus 3. So the inverse of this is simply interchange x and y. That is, x equals y squared minus 3. Then graph y equals x squared minus 3. And graph it is inverse x equals y squared minus 3. And here are the graph. Y equals x squared minus 3 is a parabola that opens up, shifted down by minus 3. And the graph of x equals y squared minus 3 is a parabola that opens to the right, shifted to the left by minus 3. Number 2 is inverse function. Given f of x equals x cubed minus 4, find its inverse, f inverse of x. So first, A, we have to show that is f of x 1 to 1. We have to show that this function is 1 to 1. If you graph this function, f of x is just, it is f of x equals x cubed shifted down by minus 4. That means if you run horizontal line test, it is going to touch the graph only at 1 point. That means yes, this f of x is 1 to 1. B, then we have to follow the 4-step process of from f of x to f inverse of x. The first process is B. Replace f of x with y and write the function. That is, y equals x cubed minus 4. So we replace f of x by y. Then the next step is C. Interchange x and y and write the function. That is, x equals y cubed minus 4. The next step is D. Solve for y and write the function. That is, y cubed equals x plus 4. That means y is cubic root of x plus 4. The last step is replace y with f inverse. Replace y with f inverse of x and write the inverse. That is, the y is replaced with f inverse of x, which is equal to cubic root of x plus 4. Number 3 is inverse functions and composition. For the function f of x, use composition of function to show that f inverse of x is as given. That is, f of x equals x plus 2 over 6, and the f inverse of x equals 6x minus 2. Show these two are inverse of each other. A, show the composition of f inverse, compose f of x is equal to x. That is, f inverse compose f of x is equal to f inverse of f of x, which is f inverse of x plus 2 over 6. You replace f of x by x plus 2 over 6. Then you substitute this x plus 2 over 6 to 6x minus 2. That is 6 times x plus 2 over 6 minus 2. The 6 cancels the 6, that is x plus 2 minus 2. 2 minus 2 is 0, that is equal to x. Then we need to show also f compose f inverse of x equal to x. That is, f compose f inverse of x is equal to f of f inverse of x, which is f of f inverse of x is 6x minus 2. Then you're going to substitute this 6x minus 2 to f of x, which is 4x. That is going to be 6x minus 2 plus 2 over 6. Minus 2 plus 2 is 0. That is 6x over 6 6 cancels 6, this gives us x. Therefore, yes, f of x equals x plus 2 over 6, and the f inverse of x equals 6x minus 2 are inverse of each other. Number 4 is exponential values. Find each of the following to 4 decimal places using a calculator. A, e to the 4, which is equal to 54.5982. 1 over e to the 4, which is e to the minus 4, which is 0.01832. Cubic root of e, which is e to the 1/3, which is 1.3956. 1 over e to the 4 to the 3rd, which is e to the minus 4 to the 3rd, which is e to the minus 12, which is 6.1442 times 10 to the minus 6. 5th root of e squared, which is e squared to the 1/5, which is e to the 2/5, which is 1.4918. And here it is using the calculator, so clear here. So it is e, second ln is e, so to the 4, and that is equal to 54.5982. Then e to the power of minus 4, it is 0.01832. E to the 1/3, is equal to 1.3956. Then e to the minus 12, and that is equal to 6.1442 times 10 to the minus 6. Then e to the 2/5, and that is equal to 1.4918. Number 5 is compound interest, which is a of t equals p times 1 plus r over n to the nt. Suppose that $950 is invested at 5% interest compounded quarterly. A, identify the value of the variable, which is p is equal to 950, that's the initial investment. The interest, which is r, is the rate is 0.05, which is 5%, and it is quarterly, that means 4 times a year, which is n is 4. B, find the function for the amount to which the investment grows after t years, that is a of t equals p times 1 plus r over n to the nt. P is 950 times 1 plus 0.05 r over 4 n to the 4t nt. So that is 950 plus 0.05 divided by 4 is 0.0125, then that is all to the power of 4t. That is a of t is 950 times 1.0125 to the power of 4t. Find the amount of money in the account at t equals 3, which is 3 years. That is a of 3 equals 950 times 1.0125 to the power of 4 times 3, which is 950 times 1.0125 to the power of 12, which is $1,102.72. Then find the amount of money in the account at t equals 12, what is in 12 years. Then a of 12 is 950 times 1.0125 to the power of 4 times 12, which is 950 times 1.0125 to the power of 48, which is $1,724.59. Then we can calculate this using TVM solver. So before we do that, first let's look at this. Just this calculation is 950 times 1.0125 to the power of 12, and that gives us $1,102.72. Then second enter, then simply change this to 48 for 12 years. Then this gives us $1,724.59. Then we can use TVM solver, finance TVM solver. N is for C, N is 3 times 4, which is 12. The interest is 5%. The initial investment is $950. We put negative because this is the money that you are taking out of your bucket for investment. PMT, we don't care, this is for annuity. P over Y is 4, C over Y is 4. PMT, we don't, again, this is for annuity, we don't care. Then you do alpha solve, you get $1,102.72. The same here. N is, it is 12 years, that is 4 times 12 is 48. I is 5. Present value, which is the investment, is 950. PMT, we don't care. Then P over Y is 4, C over Y is 4. Then alpha solve, it gives you $1,724.59. And here it is. So you go to app, finance, TVM solver. So for the first one is 3 years times 4 quarterly, so that is 12, and the interest is 5, and you are investing initially $950. We put negative because this is the money you are taking out of your bucket. PMT, we don't care, that is annuity. Then future value, that is what we are trying to calculate in 3 years. P over Y is 4, it is quarterly. C over Y is 4. PMT is, we don't care, this is for annuity. Then go to future value, which is the amount that grows in 3 years, is you do alpha solve, and that gives you $1,102.72. Then for the second one, simply change this. It is 12 years quarterly times 4, and that is 48. The interest rate is 5. The investment is 950. PMT, we don't care, that's for annuity. And we are trying to calculate the future value. P over Y is 4, C over Y is 4. PMT, we don't care, that's for annuity. Then you do alpha solve. Then you get $1,724.59. Number 6 is logarithm value. Find each of the following. Do not use a calculator. A, log base 4 of 64, and that is log base 4 of 4 to the third. 64 is 4 to the third. Bring the 3 down, that is 3 log base 4, 4. Log base 4, 4 is 1, that is 3 times 1 equals 3. Log of 10 million, so this is log of 10 to the 7, and that brings the 7 down, that is 7 log 10. Log without a base means log base 10, so that is log base 10, 10 is 1, that is 7 times 1, that is equal to 7. Log base 2 of square root of 256, and that is log base 2 square root of 256 is 16. That is log base 2, 2 to the 4, 16 is 2 to the 4. Bring the 4 down, that is 4 log base 2, 2. Log base 2, 2 is 1. That is 4 times 1, which is 4. Then ln of 1 e to the 4 to the third. That is ln e to the minus 4 to the third. That is ln e to the minus 12. Bring the minus 12 down, minus 12 ln e. Ln e is 1, that is minus 12 times 1, which is minus 12. Ln fifth root of e squared, that is ln e squared to the 1 over 5, which is ln e to the 2 over 5. That is, brings the 2 over 5 down, that is 2 over 5 ln e. Ln e is 1, that is 2 over 5 times 1, which is 2 over 5. Number 7 is exponential to logarithm conversion, converted to logarithmic equation. So a is 10 to the 6 equals 1 million. We're going to take log of both sides base 10, no base means base 10. That is log 10 to the 6 equals log of 1 million. Bring the 6 down, that is 6 log 10 equals log of 1 million. Log base 10, 10 is 1, that is 6 times 1 is 6, that is, then this is 6 equals log of 1 million. Then 3 to the minus 4 equals 1 over 81. Take log base 3 of both sides, the base is 3. Log base 3 of both sides, that is log base 3, 3 to the minus 4 equals log base 3 of 1 over 81. Bring the minus 4 down, that is minus 4 log base 3, 3 equals log base 3 of 1 over 81. Log base 3, 3 is 1, that is minus 4 equals log base 3 of 1 over 81. 4 to the half equals 2, the base is 4. Then take log base 4 of both sides. Log base 4 of 4 to the half equals log base 4 of 2. Bring the half down, that is half log base 4, 4 equals log base 4, 2. Log base 4, 4 is 1, that is half times 1, which is half, equals log base 4 of 2. So this is n to the k equals 5. The base is n, so take log base n of both sides. Log base n, n to the k equals log base n of 5. Bring the k down, k log base n, n equals log base n of 5. Log base n, n is 1, that is k times 1 equals log base n of 5, that is k equals log base n of 5. E to the 2t equals 600. So the base is e, so take log of base e of both sides, which is ln. Ln e to the 2t equals ln 600. Bring the 2t down, that is minus 2t ln e equals ln 600. Ln e is 1, that is minus 2t equals ln 600. Then t is minus ln 600 over 2. Number 8 is logarithm to exponential conversion. Convert to an exponential equation. A log 0.1 equals minus 1. Log without a base means log base 10. So this is log base 10 of 0.1 equals minus 1. Take the 10 and raise it to the minus 1, drop the log, then that is 0.1 equals 10 to the minus 1. Ln of 50 equals 3.9120. So ln minus log base e of 50 equals 3.9120. Take e, raise it to 3.9120 and drop the log, that is 50 equals e to the power of 39120. C, log base b m to the 5 equals x, that is log base b m to the 5 equals x. Take b, raise it to the x, drop the log, that is m to the 5 equals b to the x. ln z to the 7 equals h. ln is log base e, z to the 7 equals h. Take e, raise it to h, drop the log, that is z to the 7 equals e to the h. E, log base 6 of 1296 equals 4. Take 6, raise it to the 4, drop the log, that is 1296 equals 6 to the 4. Number 9 is logarithm value. Find each of the following using a calculator. Round it to 4 decimal places. A, log of 0.75, that is minus 0.1249. ln of 70, that is 4.2485. ln of 0.000054, that's minus 9.8265. log of base 2 pi of 1500. So here we need change of base. We're going to use this log base bm is equal to log m over log b, or ln m over ln b. So that is log base 2 pi of 1500 is log of 1500 over log 2 pi. Log means base 10, that is common log. Or ln of 1500 over ln 2 pi, then both of them should give you 3.979. E is log base 50 of 30. In the calculator, you don't have log base 50 of 30 or log base 2 pi of 150. So we're going to do change of base, which is log m over log b, or ln m over ln b. So that is log 30 over log 50, or ln 30 over ln 50. Both of them should give you 0.8694. And here is using the calculator. So the first one is log of 0.75. Log of 0.75, that is equal to negative 0.1249. Then ln of 70, and that is 4.2485. Then ln of 0.000054, and that is equal to minus 9.8265. Then log of 1500 divide by log of 2 pi and that is equal to 3.9792. Also, you can do natural log of 1500 divide by natural log of 2 pi and that is also 3.9792. For E, log of 30 divide by log of 50, that should give you 0.8694, and natural log of 30 divide by natural log of 50, it should give you the same answer, which is 0.8694. Number 10 is graph exponential function and its inverse logarithm function. Graph the following. A, the exponential function f of x equals 2 to the x, which is y equals 2 to the x. B, graph its inverse logarithm function, which is f inverse of x equals log base 2 of x, which is the same as x equals 2 to the y. And here is the graph. So the exponential f of x equals 2 to the x is, it crosses the y-axis at 1, so this is the exponential equation. And its inverse log base 2 of x is, it crosses the x-axis at 1, and this is the f inverse of x equals log base 2 of x. And if you look at the two graphs, they reflect each other across y equals x. And here is a calculator. So this is using the calculator, and here it is. So y, so the first one is 2 to the x, 2 to the power of x, and the other one is log base 2 of x, so we need a change of base. You can do ln or log, so we're going to do log of x divide by log of 2. Then we're going to fix the window. So the window we're going to do from -3 to 10 for x, from -3 to 10 for y, and simply graph it. And here is a graph using graphic calculator, which both of them, they reflect across the y equals x. In fact, we can graph that also. So this is y equals x, then here it is. They reflect, both of them, they reflect across y equals x. Number 11 is logarithm properties, product, power, and quotient rules. For the following: A, express a sum of logarithm and solve. So that is log base 3, 9 times 81, which is log base 3 to the 9 plus log base 3 to the 81. 9 is 3 squared, and the 81 is 3 to the 4th, that is log base 3, 3 to the squared, plus log base 3, 3 to the 4. So bring the 2 down, that is 2 log base 3, 3. Then bring the 4 down, that is 4 log base 3, 3. The log base 3, 3 is 1, that is 2 times 1 plus 4 times 1, which is 6. Then express as difference of logarithm, that is ln s plus 2 over r minus 1. This is ln a over b, that is ln a minus ln b, which is ln s plus 2 minus ln r minus 1. Then express as a product ln 6 root of 8, that is equal to ln 8 to the power of 1 over 6, and the 8 is 2 to the third, that is ln 2 to the third to the power of 1 over 6. 3 divided by 6 is half, that is ln 2 to the half. Bring the half down, that is half ln 2. Number 12 is logarithm product, power, and quotient rule, which is logarithm properties. Express the following logarithm in terms of sum and difference of logarithm. So that is log base b, fifth root of m to the 10 n to the 15 over a to the 4 b to the 6. First, we're going to write this as log base b, m to the 10, n to the 15, a to the 4, b to the 6 to the power of 1 over 5. Then I will show you two methods and use the one you feel more comfortable with. So the first method is we're going to take this log base b, m to the 10, n to the 15 over a to the 4, b to the 6. Bring the 1 over 5 down, that is 1 over 5 log base b, m to the 10, n to the 15 over a to the 4, b to the 6. Then this is equal to 1 over 5 open parenthesis log base b, m to the 10 plus log base b, n to the 15 minus log base b, a to the 4 minus log base b, b to the 6. So what is on the numerator are plus, the ones in the denominator are minus. Then this is equal to 1 over 5. Then bring the 10 down, that is 1 over 5 open parenthesis 10 log base bm plus 15 log base bn minus 4 log base ba minus 6 log base bb. Then 10 divided by 5 is 2, that is 2 log base bm. 15 divided by 5 is 3, that is 3 log base bn. Minus 4 divided by 5 is minus 4 over 5 log base ba. Then minus 6 divided by 5 is minus 6 over 5 log base b is 1, so this is just minus 6 over 5. So this is method 1. Method 2 is instead of bringing the 1 over 5 down, multiply 1 over 5 to every power. That is log base b, m 10 over 5, n 15 over 5. That is m to the power of 10 over 5, n to the power of 15 over 5, a to the power of 4 over 5, b to the power of 6 over 5. That is log base b, 10 divided by 5 is 2, that is m squared. 15 divided by 5 is 3, that is n cubed. Over a to the power of 4 over 5, b to the power of 6 over 5. Then this is equal to log base b m squared plus log base b n cubed minus log base b a to the power of 4 over 5 minus log base b b to the 6 over 5. Then bring the 2 down, that is 2 log base bm. Bring the 3 down, that is 3 log base bn. Bring the 4 over 5 down, that is minus 4 over 5 log base ba. Then bring the 6 over 5 down, that is 6 over 5 log base bb. So that is 2 log base bm plus 3 log base bn minus 4 over 5 log base ba minus 6 over 5 log base bb is 1, so that is just minus 6 over 5. And if you compare them, both of them are the same. So just pick the method you feel more comfortable, then work with it. Number 13 is logarithm product, power, and quotient rule, which is properties of logarithm. Express the following logarithm as a single logarithm. If possible, simplify. So that is log x squared minus 4x minus 5 minus log x squared minus 25. So that is log a minus log b, that is log a over b. That is log x squared minus 4x minus 5 over x squared minus 25. So that is equal to log, this can be factored as x plus 1 times x minus 5, the numerator. The denominator can be factored as x plus 5 times x minus 5. X minus 5 cancels x minus 5, then this is equal to log x plus 1 over x plus 5. Number 14 is again logarithm property, that is logarithm products, power and quotient rule. Given log base a of 2 is approximately 0.301 and log base a of 7 is approximately 0.845, find each of the following. If possible, round the answer to the nearest thousand. A, log base a of 196. So log base a of 196 can be written as log base a of 49 times 4, and that is equal to log base a 7 squared plus log base a 2 squared. 49 is 7 squared, 4 is 2 squared. Then bring the 2 down. Then this is 2 log base a 7 plus 2 log base a of 2. So this is equal to 2 times log base a of 7 is 0.845 plus 2 times log base a of 2 is 0.301. Then this is equal to 2.292. B, log base a of 4 over 49, and that can be written as log base a of 4 minus log base a of 49. That is log base a of 2 squared minus log base a of 7 squared. That is 2 log base a of 2 minus 2 log base a of 7. And that is 2 times 0.301 minus 2 times 0.84. And that is equal to minus 1.088. Number 15 is solve exponential equations. Solve the following exponential equation. We're going to solve for s. And this is e to the 6s equals 100. So to solve this, first we need to take natural log of both sides. That is ln e to the 6s equals ln 100. Then bring the 6s down. That is 6s ln e equals ln 100. ln e is 1, that is 6s times 1 is 6s equals ln 100. Divide both sides by 6, that is s equals ln 100 over 6. Number 16 is solve exponential equations. Solve the following exponential equation. We're going to solve for x, and that is 4 to the power of x squared plus 4x equals 2 to the 10. So first, figure out that if you can put both of them as base 2. And that is 4 to the power of x squared plus 4x equals 2 to the 10. But 4 is 2 squared, that is 2 squared. 2 to the power of 2 times x squared plus 4x equals 2 to the 10. So the bases are the same, 2, 2. That means if the bases are the same, then the exponentials are equal. That means 2 times x squared plus 4x equals 10. Divide both sides by 2, then x squared plus 4x equals 5. Bring the 5 to the left, then you have x squared plus 4x minus 5 equals 0. Then this can be factored as x minus 1 times x plus 5. That means either x minus 1 equal to 0, that is x equals 1, or x plus 5 equal to 0, that is x equals minus 5. So the solutions are x equals 1 and x equals minus 5. And sure enough, if you plug 1 here, so this is 1 squared is 1, 4 times 1 is 4, 1 plus 4 is 5, then 4 to the 5 is equal to 2 to the 10. The same if we do minus 5 will be the same. Number 17 is solve logarithm equation. Solve the following logarithm equation. We're going to solve for b, and that is ln 2b plus 15 minus ln b plus 3 equals ln 3. So this is ln 2b plus 15 minus ln b plus 3 equals ln 3. So the one on the left can be written as ln 2b plus 15 over b plus 3 equals ln 3. So the base are the same. This is ln, which is log base e. If the base are the same, then what is inside the base are equal. That is 2b plus 15 over b plus 3 is equal to 3. And 3 is 3 over 1. Then do cross multiplication. 1 times 2b plus 15 is 2b plus 15. 3 times b plus 3 is 3b plus 9. Then that is 15 minus 9 equals 3b minus 2b. That is b equals 6. Number 8 is solve logarithm equation. Solve the following logarithm equation. We're going to solve for x. And that is log base 4 of x plus 2 plus log base 4 of x minus 2 equals 2. Log base 4 of x plus 2 plus log base 4 of x minus 2 equals 2 can be written. This is plus, that means this is a b, that means this is log a times b, that is log base 4 x plus 2 times x minus 2 equals 2. Then to solve this is log base 4 of x squared minus 4 equals 2. Then to solve it, we're going to take the 4, raise it to the 2 and drop the log. That is x minus 4 equals 4 squared. That is x squared equals 16 plus 4. That is x squared equals 20. That is x equals square root of 20. Square root of 20 is 4 times 5. 20 is 4 times 5. Square root of 4 is 2. Then this is x equals 2 square root of 5. Number 19 is population growth. P of t equals p naught e to the kt, where k is greater than 0. In 2014, the population of the Philippines was 100 million, and the exponential growth rate was 1.84% per year. A. Identify the value of the variable p naught. So p naught is the initial population, which is 100 million. And k is the rate, so the rate of the growth was 1.84%, which is 0.0184. B. Find the exponential growth function. P of t equals p naught e to the kt, that is p of t equals 100 e to the 0.0184t. Then estimate the population of the Philippines in 2016. So 2016 from 2014 it is 2 years. T equals 2, that is p of t is equal to 100 e to the power 0.0184 times 2, which is 103.74855 million. Then when will the population of the Philippines be 150 million? And that is P of t is 150 million. That is 150 million equals 100 million times e to the 0.0184t. So divide both sides by 100, that is e to the power of 0.0184t equals 150 over 100. Then take natural log of both sides, that is ln of e to the 0.0184t equals ln of 1.5. 150 divided by 100 is 1.5. Then bring the 0.0184t down, that is 0.0184t ln e equals ln 1.5. ln E is 1, so that is T is ln of 1.5 over 0.0184, which is equal to 22.0361 years. So it's going to take about 22 years for the population of the Philippines to be 150 million. And that will be in a year 2014, that is the start, plus 22 years, that is in a year 2036, the population is going to reach 150 million. Then E is find the doubling time, that is when is the population is going to reach 200 million. So the doubling time is T equals ln 2 over K, that is T equals ln 2 over 0.0184, which is 37.67 years. So in 37.67 years, which is about 38 years, the population of Philippines is going to double to 200 million. And that is in a year 2014 plus 38, which is in a year 2052. Then we gonna use the TVM solver to calculate the population in 2 years, and the population in the years that will reach the population 150 million, and the year where the population will be doubled to the 200 million. So in C, you have N is 2 years times 1 million, because this is exponential growth, so it is increasing continuously. So if it is continuously, that means we're going to have to multiply by a big number. Then I is 1.84. The initial population is 100. PMT, we don't care, this is for annuity. Then P over Y is 1 million. C over Y is 1 million. So it is increasing every year by 1 million, because that's exponential growth. Then the feature value, which is in 2 years, you do alpha solve, then it's going to reach 103.74, which is about 104 million. Then N, we're going to find this. The rate is 1.84. The initial population is 100 million. PMT, we don't care, this is annuity. The feature is it is going to reach 150 million. P over Y is 1 million. C over Y is 1 million. PMT, we don't care. Then when we go to N and do alpha solve, it gives us 22 million. Then when we divide this by a million, then this is 22.036 years. Here the rate is 1.84. The initial population is 100. It is going to double to 200 million. P over Y is 1 million. C over Y is 1 million. Then when you go to N, do alpha solve, it's going to 37.67 million. And when you divide this by a million, that is 36.67 years. And here it is. And this clear. So go to App, Finance, TVM Solver. So the first one, N is 2 years, 2 times 1 million. 1, 2, 3, 1, 2, 3. That is 2 million. And it is, the rate is 1.84, 1.84. And the initial population is 100 million, so that is 100 million. PMT, we don't care. The feature, that is what we are trying to calculate. Then P over Y is 1 million. This is a continuous growth. Okay. Then C over Y is also 1 million. Then you go to, in 2 years, alpha solve, it is going to be 103.75 million. Then for D, we are trying to find N, that is 0. Then this is 1.84. The initial is 100 million. PMT, we don't care. And it is going to reach 150 million in the future. And P over Y is 1 million. C over Y is 1 million. Then you're going to go to N, alpha solve, and that gives you 22 million. Divide this by a million, then that's 22.0361 years. Then on E, we are trying to calculate N. The I is 1.84. The initial population is 100 million. PMT, we don't care, that's for annuity. And it is going to double to the 200 million. P over Y is 1 million. C over Y is 1 million. Then go back to N, alpha solve, and that gives you 37.67 million. When you divide this by a million, then that is 36.67 years. And that is 2050. Number 20 is interest compounded continuously, which is P of t equals P naught e to the kt, where k is greater than 0. Suppose that 950 is invested at 5% interest per year compounded continuously. So this is the same as population growth. The concept is the same, except over there population grows, here it is money growth. And this is the same as we have seen in number 5. So in number 5 we have, it was growing, the 950 was growing quarterly, which is 4 times a year. Here it is going to grow continuously, and that is why it's P of t equals P naught e to the kt. So A is identify the value of the variable. So initially it is 950 is invested, and the rate is 5%, which is 0.05. So find the exponential function that describes the amount in the account after t years, t in years. That is P of t equals P naught e to the kt. That is P of t equals 950 times e to the 0.05 t. Then find the balance after 3 years. That is t equals 3. That is P of 3 is 950 times e to the power of 0.05 times 3, which is 1103.74. Then what is the doubling time? That is the doubling time, which is when is the money is going to be twice of 950, and that is t equals ln2 over k, which is ln2 over 0.05. That is in 13.8629 years, the money is going to double twice of this. So now if you compare number 20 to number 5, in 3 years in number 5 we got $1,102.72. Here we got $1,103.74. In number 5 it was growing quarterly, which is 4 times a year, but here it is growing every second continuously, but the difference is only $1. So that means whether the money is growing quarterly or semi-annually or monthly or yearly or daily or continuously, the difference is extremely small. So here it is continuously, the difference is only $1. So that means if you invest 950 in the bank, if it is quarterly, it is 1,102. If it is continuously, it is 1,103, which is you get only $1 more. Then You can use TVM solver, but before we use TVM solver, we can actually get out of here. So this is 950 e to the power of 0.05 times 3 years times 3. And that gives you equal to $1,103.74. Then you can use TVM solver. So this is growing continuously. So n is 3 years, that is 3 times a million. So it is growing a million times a year. So that is 3 times a million. The interest rate is 5, and the initial investment is $950. PMT, we don't care. P over Y is 1 million. C over Y is 1 million. PMT, we don't care. This is annuity. Then you do alpha solve, you get $1,103.74. And for the doubling, we're going to calculate N. I is 5. The initial investment is 950. PMT, we don't care. That is for annuity. Then it is going to double to 1,900. P over Y is 1 million. C over Y is 1 million. PMT, we don't care. It is annuity. Then we come to N. We do alpha solve. Then you get 13.86 million. When you divide this by million, then you get 13.8629 years. And here it is. So you go to App, Finance, TVM solver. So initially N is 3 years times 1 million, because this is growing continuously. Then I is 5, it is 5% the rate, and the initial it is $950. PMT, we don't care, we leave it 0. And feature values, this is what we are trying to calculate, so we put it 0. Then P over Y is 1 million, C over Y is 1 million. Then you go to the feature value, which is in 3 years. You do alpha solve, and that is $1,103.74. Then if you want to find the doubling time, so we are trying to find the N, so you turn this to 0. I is 5, the initial investment is $950. PMT, we don't care. Then doubling is going to double from 950 to 1900, 1900. Okay. P over Y is 1 million, C over Y is 1 million. Then go to N, alpha solve, and you get 13.86 million. When you divide this by a million, that is 13.8629 years, which is about 14 years. So the money will double to 1,900 in about 14 years. Number 21 is Gauss-Jordan elimination. Solve the system of equations using Gauss-Jordan elimination, that is, create the augmented matrix, perform elimination to reduce the row echelon form, that is, ones in the diagonal, 0 above and below the diagonal, and the result is AB. That means x equals A, y equals B is your final solution. So this is 2x plus y equals 1. 3x plus 2y equals minus 2. Then we're going to create a matrix that is x is 2, 3. For y, it is 1, 2, augmented with 1 minus 2. Then the first thing is we're going to turn the 2 to 1. Divide row number 1 by 2. 2 divided by 2 is 1. 1 divided by 2 is half. 1 divided by 2 is half. And keep row number 2 as it is. Then we're going to turn this to 0. To turn this to 0, keep row number 1 as it is, 1 half half. Then multiply row number 1 by minus 3 and add it to row number 2. So that is minus 3 times 1 is minus 3, minus 3 plus 3 is 0. Minus 3 times half is minus 3 over 2, plus 2 is half. Minus 3 times half is minus 3 over 2, minus 3 over 2 minus 2 is minus 7 over 2. Now we're going to change this, we're going to change this to 1, multiply row number 2 by 2, and keep row number 1 as it is. So that is 1 half and half, then 2 times 0 is 0. 2 times half is 1. 2 times minus 7 over 2 is minus 7. Then we're going to change this to 0. To change this to 0, you're going to keep row number 2 as it is, 0, 1, minus 7. Then you're going to change this to 0. So you're going to multiply row number 2 by minus half and add it to row number 1. So this is 0, 1, minus 7. Minus half times 0 is 0. 0 plus 1 is 1. Minus half times 1 is minus half. Minus half plus half is 0. Minus half times minus 7 is 7 over 2. 7 over 2 plus 1 over 2 is 8 over 2. 8 over 2 is 4. So that is 4. So now this is reduced row echelon form. You have 1 in the diagonal and 0 above and below the diagonal. That means 1, 1, 0, 0. That means x equals 4 and y equals minus 7. That is x times 1 is x, 0, y times 0 is 0, that is x equals 4. X times 0 is 0, y times 1 is y, that is y equals minus 7. The solution is then xy equals 4 minus 7. X is 4, y is minus 7. 22 is another Gauss elimination. Solve the system of equation using Gauss elimination. That is, create the augmented matrix, perform elimination to row echelon form, which is 1, 1 in the diagonal, 0 below the diagonal, and A above the diagonal, B, C. Note when 0 equals 0 means infinitely many solution, and 0 equals a constant k means no solution. So this is minus 2x plus 6y equals 3, x minus 3y equals 8. Then we're going to put this converted into matrix. For x is minus 2, 1, for y 6 minus 3, augmented with 3, 8. Then we need 1 at the top, so simply interchange row 1 and 2. Then that row 1 is now 1 minus 3, 8, and row 2 is minus 2, 6, 3. Then we're going to eliminate minus 2 to 0. Then keep row number 1 as it is, 1 minus 3, 8. Multiply row number 1 by 2 and add it to row number 2. So that is 2 times 1 is 2. 2 minus 2 is 0. 2 times minus 3 is minus 6. Minus 6 plus 6 is 0. 2 times 8 is 16. 16 plus 3 is 19. This means you have 1 minus 3, 8, 0, 0, 19. So this is x times 0 is 0, y times 0 is 0. That means 0 equals 19. And this is false. Of course, 0 is not equal to 19. It is false. That means no solution. And that is what it says here. When 0 equals some constant, which is 0 equals 19, that is no solution. Number 23 is another Gauss elimination. Solve the system of equation using Gauss elimination, that is, create the augmented matrix, perform elimination to row echelon form, that is 1 in the diagonal, 0 below the diagonal, and A above the diagonal, and the result is BC. Note 0 equals 0 means infinitely many solution, and 0 equals K constant means no solution. So the equation is, the system is 3x minus 9y equals minus 6 minus 2x plus 6y equals 4. And we're going to convert this to matrix. For x you have 3 minus 2, for y minus 9, 6, augmented with minus 6, 4. So we need here 1. If you multiply row number 1 by, if you divide row number 1 by 3 and keep row number 2 as it is, then 3 divided by 3 is 1, minus 9 divided by 3 is minus 3, minus 6 divided by 3 is minus 2. And keep row number 2 as it is, minus 2, 6, 4. Then we need 0 below 1. Then we're going to multiply row number 1 by 2 and add it to row number 2. So keep row number 1 as it is, 1 minus 3 minus 2. Then 2 times 1 is 2, 2 plus minus 2 is 0. 2 times minus 3 is minus 6, minus 6 plus 6 is 0. 2 times minus 2 is minus 4, minus 4 plus 4 is 0. So here notice you have 0, 0, 0. So that means you have x times 0 is 0, y times 0 is 0, and that is equal to 0. That is 0 equals 0. That means you have infinitely many solutions. To get those infinitely many solutions, so let y equals y, y will be independent variable, then x is going to depend on y. That is x minus 3y equals minus 2. That means x equals 3y minus 2. So the infinitely many solution xy is, x is 3y minus 2, and y is just y, where y is from minus infinity to infinity. Now let's look some of the values. So for example, if y is minus 100, is from minus infinity to infinity, if y is minus 100, then xy is, x is 3y minus 2y is y, that is y is minus 100, and the x is 300 minus 300 minus 2, which is minus 302. When y is minus 2, x is 3 times minus 2 is minus 6, minus 6 minus 2 is minus 8. When y is minus 1, x is 3 times minus 1 is minus 3, minus 3 minus 2 is minus 5. When y is 0, then x is 3 times 0 minus 2, which is minus 2. When y is 1, then x is 3 times 1 minus 2, which is 1. When y is 2, 3 times 2 is 6, 6 minus 2 is 4. then x is 4. When y is 100, then 3 times 100 is 300, 300 minus 2 is 298. Then you go to infinity with the negative and to infinity with the positive. And that is infinitely many solutions. Number 24 is another Gauss-Jordan elimination. So use Gauss-Jordan elimination to solve the following system. Except this one is 3 variables, 3 unknowns, and 3 equations. That is 2x minus y plus 4z equals minus 3, x minus 2y minus 10z equals minus 6, 3x plus 4z equals 7. So we're going to convert this to matrix. So for x you have 2, 1, 3. For y minus 1 minus 2, 0. For z 4 minus 10, 4. Augmented with minus 3 minus 6, 7. And our goal is to do Gauss-Jordan elimination and to convert this to reduced echelon form, which is ones in the diagonal, 0 above the diagonal and 0 below the diagonal, and the result is ABC, which is x equals A, y equals B, z equals C. So the first thing is we need 1 at the top. So we can interchange row number 1 and number 2. Then that will give us row number 1 will be 1 minus 2 minus 10 minus 6. Row number 2 will be 2 minus 1, 4 and minus 3. And row number 3 will be as it is, 3, 0, 4, 7. Then we need 0 below 1, 0, 0. So we need to turn this to 0, we need to turn this 0. And to do that, multiply row number 1 by minus 2 and add it to row number 2. Multiply row number 1 by minus 3 and add it to row number 3. And keep row number 1 as it is. So that is 1 minus 2 minus 10 minus 6. Minus 2 times 1 is minus 2, minus 2 plus 2 is 0. Minus 2 times minus 2 is 4, 4 minus 1 is 3. Minus 2 times minus 10 is 20, 20 plus 4 is 24. Minus 2 times minus 6 is 12, 12 minus 3 is 9. Then turn this to 0. Minus 3 times 1 is minus 3, minus 3 plus 3 is 0. Minus 3 times minus 2 is 6, 6 plus 0 is 6. Minus 3 times minus 10 is 30, 30 plus 4 is 34. Minus 3 times minus 6 is 18, 18 plus 7 is 25. Then you have 1, 0, 0. Then you need to turn this to 1. To turn this to 1, simply multiply row number 2 by 1/3 or divide it by 3. So then keep row number 1 as it is, 1 minus 2 minus 10 minus 6. Row number 3 as it is, 0, 6, 34, 25. Then row number 2, 0 divided by 3 is 0. 3 divided by 3 is 1. 24 divided by 3 is 8. 9 divided by 3 is 3. Then you have now 1, 0, 0, 1. So now we need to turn this to 0. To do that, keep row number 1 as it is, 1 minus 2 minus 10 minus 6. Keep row number 2 as it is, 0, 1, 8, 3. Then multiply row number 2 by minus 6 and add it to row number 3. Minus 6 times 0 is 0. 0 plus 0 is 0. Minus 6 times 1 is minus 6. Minus 6 plus 6 is 0. Minus 6 times 8 is minus 42. Minus 42 plus 34 is minus 14. Minus 6 times 3 is minus 18. Minus 18 plus 25 is 7. Then you have now 1, 0, 0, 1, 0. Then you need to turn this to 1. Simply multiply row number 3 by minus 1 over 14, or divide row number 3 by minus 14. So keep row number 1 and 2 as they are. 1 minus 2 minus 10 minus 6. 0, 1, 8, 3. Then divide 0 divided by minus 14 is 0. 0 divided by minus 14 is 0. Minus 14 divided by minus 14 is 1. 7 divided by minus 14 is minus half. Now we have this in row echelon form. 1, 1, 1 in the diagonal, zeros below the diagonal, and A, B, C, some numbers above the diagonal. The result is minus 6, 3, minus half. So from here it is, this is row echelon form. So here we can do back substitution to solve it from here. Z is minus half, and back substitute to get X and Y. But if you continue, then you get it to row, reduced row echelon form. And that is, we're going to turn this to 0, this to 0, this to 0. To do that, we're going to turn first 8 to 0, minus 10 to 0. To do that, keep row number 3 as it is. Multiply row number 3 by minus 8, and add it to row number 2. Multiply row number 3 by 10 and add it to row number 1. And that is 0, 0, 1. You keep row number 3 as it is. 0, 0, 1 minus half. Then minus 8 times 0 is 0. 0 plus 0 is 0. Minus 8 times 0 is 0. 0 plus 1 is 1. Minus 8 times 1 is minus 8. Minus 8 plus 8 is 0. Minus 8 times minus half is 4. 4 plus 3 is 7. Okay. Then multiply row number 3 by 10 and add it to row number 1. 10 times 0 is 0. 0 plus 1 is 1. 10 times 0 is 0. 0 minus 2 is minus 2. 10 times 1 is 10. 10 minus 10 is 0. 10 times minus half is minus 5. Minus 5 minus 6 is minus 11. So now we have 1 in the diagonal, 0 below the diagonal. Then you need to turn this to 0. To turn this to 0, simply multiply row number 2 by 2 and add it to row number 1. So keep row number 3 as it is. 0, 0, 1, half. Keep row number 2 as it is. 0, 1, 0, 7. Then multiply row number 2 by 2. 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 minus 2 is 0. 2 times 0 is 0. 0 plus 1, 0 is 0. 2 times 7 is 14. 14 minus 11 is 3. Now we have reduced echelon form, where you have 1 in the diagonal, zeros below the diagonal, and zeros above the diagonal. And the result is 3, 7 minus half. That is x equals 3, y equals 7, and z equals minus half. You can create a matrix called A, which is 2, 1, 3, minus 1, minus 2, 0, 4, minus 10, 4, minus 3 minus 6, 7, and this is in TI-84 plus. You create this matrix, then use ref A to get the solution. So the solution is 1 0 0 0 1 0 0 0 1. The result is 3 7 minus half, which is x equals 3, y equals 7, z equals minus half. I have an application, I have a video on system of equations on applications. Please watch that video. I have several applications where I solve system of equations using TI-84 plus. Number 25 is linear programming graphic method. Linear programming is a mathematical modeling technique in which linear functions is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and in social and physical science. In business maths, we analyze both graphical method and simplex method. In this exam review, we will analyze graphic method. The application is maximizing profit. Dovetail Carpenter Shop makes bookcases and desks. Each bookcase requires 5 hours of woodworking and 4 hours of finishing. Each desk requires 10 hours of woodworking and 3 hours of finishing. Each month, the shop has 600 hours of labor available for woodworking and 240 hours for finishing. The profit on each bookcase is $40 and on each desk is $75. How many of each product should be made each month in order to maximize the profit? What is the maximum profit? So the first thing is we need to convert this, the word problem, we're going to convert it into a table. We have two products, bookcases and desks, and we don't know how many bookcases and how many desks we need to make to maximize the profit. So we're going to call them X bookcases and Y desks. Then the woodwork for the bookcases requires 5 hours and the finish requires 4 hours. And the profit is $40 each bookcase. And for the desk we require 10 hours for woodworking and 3 hours for finishing. And the profit is $75. And the constraints are we have only 600 hours for woodworking. That means we can use only 600 hours or less. Then for finishing we can use the maximum 240 hours or less. And the objective is to maximize the profit. So the objective function is maximizing the objective function. The profit is 40x plus 75y, and this is what we are trying to maximize. Of course, it is subject to the constraints, that is 5x plus 10y is the maximum you can use is 600 hours or less. Then 4x plus 3y, the maximum you can use is 240 hours, that is less or equal to 240 hours. Of course, you have to produce 0 or more bookcases. and you have to produce 0 or more disks. That means x is greater or equal to 0. So we're going to take this constraints, we're going to convert it into graphic and get the feasibility region. So first is x has to be equal or greater than 0, that means above the x-axis. Y has to be greater or equal to 0, that means to the right of y-axis. Then we have to take 5x plus 10y equals 600 and graph a line. Then 4x plus 3y equals 240 and graph the other line. So here when x is 0, y is 60. So when x is 0, y is 60. That is 1 point. Then when y is 0, x is 120. And that is the first line. Then we need to graph 4x plus 3y equals 240. When x is 0, y is 80. And that is this point. When y is 0, x is 60. And that is 60, 0. And that is the other line. Then you have 5x plus 10y is less or equal to 600, means below this line. And 4x plus 3y less or equal to 240 means below this line. That means the feasibility region is above x-axis, to the right of y-axis, below this line, and below this line. So this is the feasibility region. That means in the feasibility region, every point in the feasibility region is a profit. Then the maximum profit is at the corner of the feasibility region, and the minimum profit is also at the corner of the feasibility region. Then all we have to do is evaluate the objective function, which is profit equals 40x plus 75y at the corner points at 0, 0, at 0, 60, at 60, 0, and at 24, 48. But now how do you get this 24, 48? To get this 24, 48, we need to solve 5x plus 10y equals 600 and 4x plus 3y equals 240 simultaneously. Then find what is x, what is y. You can do substitution method, or you can just put it in the calculator. Create a matrix called F, and that matrix is for x is 5, 4, for y is 10, 3, then augmented with 600, 240, then do ref f, then that is 1001, and the result is 2448. That is, this corner is 2448. Then evaluate the objective function, which is the profit 40x plus 75 at the corner points. So first evaluated at 0, 0, that is 40, profit equals 40 times 0 plus 75 times 0, that is 0. Then evaluated at 60, 0, at this point, then profit equals 40 times 60 plus 75 times 0, which is 2400. Then evaluated at 2448, then profit is 40 times 24 plus 75 times 48, that is 4560. Then evaluated at 0.60, then the profit is 40 times 0 plus 75 times 60, which is 4500. So now here you have 0, 2400, 4560, and 4500, which is the maximum is 4560, and this is the absolute max. and this is when you produce 24 bookcases and 48 desks, then you will end up with a maximum profit. And the absolute minimum is 0. When you produce 0 bookcases and 0 desks, then you make nothing, it is 0. So that means you have xy, x is bookcases, y is desks, is 24, 48. So when you make 24 bookcases and 48 desks, then your maximum profit is going to be 4,560. That is, the carpenter shop will make a maximum profit of 4,560 when 24 bookcases and 48 desks are produced and sold. And this is when you have 2 by 2 variable, you can do graphic method, but when it is 3 by 3 or 4 by 4 or 100 by 100 for that matter, or 1000 by 1000 like they do in Amazon, then doing solving graphic method becomes almost impossible. Then you have to use the other method, which is called simplex method. And the simplex method, you can use a calculator, but the best way to solve simplex method is using Excel sheet. And that is what big businesses like Amazon, they use Excel sheet or some kind of programming to solve a multivariable, could be 100 variable, 1000 variables, and that's what they use. And thank you. Please subscribe, share, and like, and ask your friends to subscribe, share, and like.